Hi, my name is Lucas Kwan, and I'm here today to answer the question, why do fireworks produce different colors? In order to do this, we'll use aluminum as an example. Aluminum is located in the boron family and in the third period. We also know that the aluminum has 13 protons, around 13 neutrons, 3 electron levels, and a total of 13 electrons. We also know that aluminum is a solid at room temperature and is not very reactive. We also know that the aluminum atom has a total of 3 orbitals. The orbital that's closest to the nucleus contains 2 electrons. The middle one contains 8 electrons, and the third one contains 3 electrons. While aluminum only has a total of 13 electrons, thallium has a total of 81 electrons. It's also in the 6th period, as well it's in the boron family. Since it's in the boron family, it has a total of 3 valence electrons. Now that we know some facts about the element aluminum, now we can start answering the main question. But first, we have to explain how light is made. Light is made when energy is added to an atom. When this happens, the electrons enter an excited state and move to a further orbital in the atom. The more energy added, the further the electron goes. This happens because when energy is added to an atom, the attractive forces between the protons and electrons of the atom are weakened. When energy is added to an atom, the electrons are able to escape the attractive forces of the protons and move to a further orbital. But however, when energy hasn't been added to the atom, the electrons stay closer to the nucleus where the protons are. After gaining energy, the electrons emit the gained energy and return to their grounded state. Without the excess energy, the protons are able to pull the electrons back to their original energy level. The electrons emit the excess energy in the form of wavelengths. This is how photons and the light emitted from an atom is made. When aluminum is a material in a firework, it emits a silver light. However, this means that each aluminum atom has to be raised to a different energy level to produce that silver light, because silver light is not made out of one specific type of wavelength. Silver and white light is different from colors like blue and red. Blue and red light is mostly made out of one type of wavelength that produces red or blue light, but silver and white light is made out of a mixture of wavelengths in the visible spectra. But since a single atom can only emit one wavelength at a time, different atoms have to be raised to different energy levels to release different wavelengths that mix into that silver light. So atoms that are raised to a higher energy level produce violet light because wavelengths that produce violet light have a higher frequency. This happens because more energy is needed to produce more disturbances in the light wave. The red light is produced when there is less energy because the wavelengths are less frequent. Other colors that are in the silver light are produced when the atoms are raised to an energy level in between the ones needed for violet and red light. Well, that explains how aluminum fireworks produce silver light, but you might be wondering why there are other fireworks with different colors. The answer is that each element and its electron require a unique amount of energy for the electron to move to the next orbital. This means that when two different elements are given the same amount of energy, their electrons might move through different amounts of orbitals. If this happens, the color produced by these atoms would be different. So that answers why different fireworks produce different colors. Thanks for watching!